I'd love to hear from you kind of what you're doing in this realm of microbiology, looking at pigmentation and why there could be purple planets out there.
My work is on trying to constrain what sort of life we could detect possibly in the surface of an exoplanet. And in my point of view, that is better achieved if we look for biopigments. Biopigments is a biomolecule that all living things can produce. We produce melanin, for instance. And the reason why we produce it is to fight the stresses of our environment. So our melanin is for UV. But in other organisms, it can be for them to have protection against desiccation, protection against lack of resources. Think of flamingos. The pinkest flamingo is the one that is luckier in the reproduction dance, right? So biopigments are here to help us survive. And also, they help us survive a lot of the things that I call the weather forecast in space, which is radiation, lack of resources, dryness, changes in temperature, and all this. They also have an amazing thing about them is that they are incredibly detectable with spectroscopy, which again, it's what we are always going to have and only going to have in these telescopes looking at exoplanets. So whatever biology we are trying to find on an exoplanet, we're always going to have to translate all this amazing biology into just one language, which is spectroscopy. And biopigments do that extremely well. So what I've been doing, and I've been going to the field, getting all these colors of surfaces and bringing them to the lab and growing them and measuring their reflectance so that one day observers are going to have all the references needed to not miss any sign of a biopigment on the surface. I'm also creating these models that make it more easy for adapting to every type of telescope. So the idea is to not do as much of follow the water, but instead follow the color for the surface on an exoplanet with direct imaging.